In this video, we will learn vector addition using triangle law and parallelogram law. And before we proceed, if you have not subscribed to the channel, I would recommend you to subscribe because we will be posting more videos, further videos on on the same topic and on different topics, and I'm sure that you will be benefited to as you keep viewing our channel. And our main motto is to make maths easy and understandable at the same time you're able to apply it and master it. So let's proceed. Now let's consider two vectors A and B, right? And let's assume that these vectors A and vector B are acting on an object which is placed at the origin here, just for assumption. Okay, so when this vector A and vector B are in a line of action on an object placed on this origin here, what's going to happen? There is going to be two actions taking place at the same time, both in magnitude and in direction. So it's going to move in a direction something like this. So the direction of the resultant vector would be in this direction. And then what we will do is, let's move the vector A into our x-axis for understanding, and B into the high up into the y-axis. So we're going to place the origin of A and the origin of B at the origin of the object. So we have done that here. Okay, so after doing that, we're going to move this vector B, or we're going to translate it to the point where the vector A ends. So let's do that. Okay, so vector A plus the vector B would give you a resultant vector which will start from the origin of vector A and end at the terminal point of vector B. Okay, let's make it more easy for you to understand with the illustration. Illustrations are always easy for us to understand. Now visualize a pine tree. Now you have two woodcutters who want to come and push this tree down. Let's assume they're very strong men and they can actually do it. So we have two guys here putting their pressure on this object, which is a tree, and it's in this direction. So that's their line of action. So when the line of action is in this direction, we know by common sense which direction will the tree fall. Can you tell me? Will it fall on this direction? No. 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 Even though the force is going on this direction, there's another force coming from here. So it will end falling in this direction. Okay? So I want you to visualize, when we look at vectors, how the forces are changing the direction of the vector. So two vectors acting have a resultant direction on the vector that is the final vector. Now let's assume this is a wood block, and the same force is applied by these two people here. Now the wood block will begin to move in distance. So I'm going to call this as magnitude. First we saw direction, this is magnitude. So when this force is applied in this two direction, there will be a magnitude of movement that will take place, and it's going to be in this direction, and this might be the actual amount of movement that would take place. How much is this going to move? We know it's in this direction, but how much is going to move is going to be our question. So it depends on how much is this force and how much is this force, and that will result on how much is this movement. So if we call this is vector A and this is vector B, and they're added together, their forces added together, then you get the resultant vector C, so which moves this object to that space. So vectors are imaginary figures or imaginary lines which brings us an understanding of something that's actually happening in the real world. Right, let's go back to our original drawing. I'm going to place the wood block here and I'm going to apply the force, like I said. So then this is going to move in this direction. Okay. Now how much has this moved? What is this length here? That's our addition. So just as we had moved our origin of A to the origin of the block or its original position. So I've moved A over here and I've moved B over here. Okay. The origin of B has moved to the origin of the place of the original place of the block. Okay. So now I'm going to translate this B vector to at the end of vector A. So which is this. So you have vector A plus the vector B, which gives you the resultant action vector, and that's the place where our original block has moved. Alright, so summarizing, vector A plus vector B gives you this vector here, which has a certain length and has a certain direction. Alright, and its length is between the origin of A and the terminal point of B, and its direction is also from the origin of A and the terminal point of B. So let's assume this is vector A and vector B, and let's move vector B here for our purpose of addition. So AB plus BC would give us AC vector. Okay, right. So consider two vectors, vector A and vector B. So any given two vectors, vector A and vector B, if we're going to add them up, then what you should do is first take vector A, place it, then take vector B and place it at the end of vector A. So the B, the beginning or the origin of B would come and sit exactly at the terminal point of B. So that's how we do it. All right. Now the resultant, the resultant vector after adding the A and the B is this vector here. So we call that as vector C, which starts from the origin of A and ends at the terminal point of B. But if you notice, this is in the reverse direction. If this is a triangle and we start the triangle from here as the vector goes, and then it goes like this in this direction, vector B, but it doesn't come back here, but it goes in the opposite direction. So we can call, if two vectors are represented in magnitude and in direction by the two sides of a triangle, okay, so we're going to represent them with magnitude and direction by two sides of a triangle, then their sum is represented by the third side in the reverse order. I hope this has brought the definition of triangle law easy to you. Okay, so that's our triangle law. So you don't have to be worried anymore about the triangle law, trying to understand it. Now let's go to the parallelogram law. Now parallelogram law is applied when you have two vectors which have the same initial point. In the previous, they didn't have the same initial point. Okay, but if they have the same initial point, and you have vector A and vector B, then the sum of these two vectors can be represented as a parallelogram. Let me explain to you how. So let's draw a line AC. So when I say AC, it starts from here A and is parallel to OB. Parallel to OB, draw a line here AC. Okay, I've done that. Now, we can call our OC as the sum of vector A plus vector B, right? So you can see that OACB, all right, OABC is a parallelogram, right? It's a parallelogram. So if you want to find the sum of two vectors which have the same origin, then draw a parallelogram with A and B as adjacent sides. So keep A and B as adjacent sides and draw a parallelogram. How would you do that? You would draw this line, take the parallel line of this and draw it here and call it AC, and then connect the end two points, then you will get a parallelogram. And this diagonal line here is the diagonal line is the sum and maintains the same initial point. So it maintains the same initial point and the diagonal line is the sum. I hope that has given you an introduction to addition in vector algebra. Thank you for watching Math Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.